Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nur Hafiz bin Mustafa, a PhD student at the University Putra Malaysia. So normally in our lab we focus on the third generation solar cell, which is dye-sensitized solar cell. It consists of four main components, which is photoanode, counter-electrode, electrolyte, and dye. Okay, how DSSC works? DSSC works when the photon from the sunlight struck the dye molecule. The dye molecule undergo oxidation and release an electron. So the electron released from the oxidation process travel from one TiO2 to another TiO2, creating electron hole junction. This electron hole junction create a potential. So then the electron moves to the counter electrode that acts as a catalyst to enable the electron to recombine with the electrolyte. So what happened that the electrolyte undergo redox process, oxidation and reduction. The oxidation of the electrolyte release an electron, and the electron comes back to the dye, and the process is complete. The process repeats again and again 1000 times per second to produce a new energy. Okay, titanium dioxide as photoanode in DSSC has faced a lot of drawback, which is low dye loading capacity, small range of light scattering, high recombination effect, and low charge transport ability that reduce its power conversion efficiency, that reduce the we call that final DSSC device of performance. Consequences in our lab, we try to produce a photoanode that have a promising trait, which is has broad range of light scattering ability. We try to incorporate compact layer into the photoanode to reduce the recombination effect, and also we try our best to provide a material that have broad light scattering and hard surface area. With all of these promising traits, we can increase the performance of our dye-sensitized solar cell device, that we can produce more energy in terms of renewable energy. So now we know the problem arise, so we know how to counter it. So what is the benefit? So in Malaysia, so how is it benefit? So when we produce a new energy from the solar energy, because we got the sunlight almost 12 hours per day, it's very, what we call that, waste if not use it. So the important thing is we can produce renewable energy to substitute the non-renewable energy. So in this case, nowadays in Malaysia, because when we done a lot of research, not all of the research paper were published with high power conversion efficiency. We try to produce, to fight with a good manner with the other country to produce a very high power conversion efficiency, that in the end we can make the work publishable and we can make the work implemented into the industry. That because in terms of solar cell, it is less known in Malaysia, because when we go to the houses, only the rich houses area have the solar panel because it's very expensive. So what we did, we tried to reduce the cost. When we reduce the cost, each of the Malaysian can have even one DSSC device in their house to produce renewable energy, which can save the electricity, can be saved for the next generation. As in a nutshell, to conclude, before we end this video, is about the competition. So how competitive is this research study about solar energy in Malaysia? So it's very competitive around the research university, UPM, UKM, USM, and others university. So what we try to produce is we try to produce a DSSC, which is a third generation solar cell. We also try to produce a flexible solar cell that can be also be a wearable, so we can also wear in the textile, so it can be, we can get the power everywhere. Okay, in the end, what we did is, even the competition is higher, we try to increase the standard. So even in our lab, in our university, we want to try to come up with a complete DSSC device that can achieve up to 12%. So now we get around 4%. It's very long journey, but keep trying by trying to produce a new renewable energy with a lower cost, flexible and also wearable. Thank you very much.